Hello and very welcome to the SliceNet webinar series. Just a little background, first of all, in terms of 5G network slicing, for those of you who don't know, it splits the network resources into logical or virtual networks, which are called slices, which helps to address use cases or applications which have distinct characteristics and service level agreement requirements. The 5G SliceNet project aims to enable 5G slices for verticals to achieve demanding use cases and manage the quality of experience for slice services. SliceNet is following a layered architectural approach to allow the creation of a modular, extensible and scalable framework. So today we start with our very first webinar from SliceNet with our presenter, Ciriaco Angelo. Ciriaco is Senior System Manager with Ericsson Research and Development, and he is based in Italy. He has worked with many core network Ericsson products, and he was the Ericsson delegate, in fact, for 3GPP standardization, and has some patents filed. Ciriaco always likes to learn and be at the front edge of telecommunications with new technologies and architectures. Therefore, he is involved in leading a major part of the work on the 5G control plane within the SliceNet project. The title of today's webinar is 5G Multi-Domain Slice Control Plane. The purpose of the webinar today is to let you know about SliceNet's technical achievements and innovations with a focus on the control plane aspects. And just to ask you if you could all go on mute so that we can all hear properly. We will have time for questions halfway through the presentation and again at the end of the presentation. I will keep an eye on the chat box so that if anyone wishes to ask a question or make a comment, please feel free to type this into the chat box and I can bring this up at the end. Or you can ask the question yourself. So for now, sit back and enjoy, and I'll pass you over to Ciriaco now.
Okay, good morning and welcome to this webinar. This is the menu. I'll first introduce network slicing as a concept and then the overall SliceNet framework system architecture in order to put in the right context the control plane, which is the very subject for this seminar. After that, we can dig a little bit with the technical details of the control plane, also the major innovations we have introduced, the prototyping work we have done, and also we'll touch at the end industry vertical applications that make use of our framework. And of course, question and answers. So let's introduce quickly network slicing. Here you see a typical network composed by typical network segments like radio access, edge, mobile core, and so on. Assuming you want to run a number of 5G use cases on this network, then it's nearly impossible to optimize the network so to satisfy all the different requirements from different 5G use case. The solution to this problem offered by network slicing is to simply slice the network, meaning that a number of slices are created and made available, assigned to each 5G use case, so that in a nutshell, each 5G use cases can run and see its own slice as a kind of private subnetwork that can be therefore optimized in complete isolation from the others. That's why we say that network slicing is actually a promising solution to enable diverse 5G use cases with their demanding quality of service and quality of experience requirements. Then we can introduce the SliceNet project. First of all, the technical challenge is to design and prototype a framework for the management and the control of the network slices. Of course, We do it leveraging the software-defined network and network function virtualization technologies, also adding some cognitive techniques and artificial intelligence. The project is part of the 5G infrastructure project and is within the European Horizon 2020 program for research and development. As usual in this project, there are a number of partners from all over Europe. There are both telecom vendors, telecom operators, as well as small and medium enterprises. Just to mention one, that is Ericsson, the company where I'm from. A quick look on the SliceNet system architecture. As you see, the system is divided in planes. But let's look at briefly the main functionality, so to understand what those planes does. You can see there is a catalog of network slices that is offered to the vertical through the access plane. Once the vertical has chosen the slice that best suits him, he can order the instantiation of the slice. And then we come to the provisioning process that is carried out mainly by the orchestration and the control plane. Then the slice is live, I'd say, carrying traffic, and therefore it can be monitored. That's the job of the monitoring plane here. That's collecting a number of performance indicators. And this monitoring can, of course, be offered again to the vertical through the access plane. You see there is also a cognition plane here. The job of the cognition plane is mainly to keep the slice optimized during its life. We will see a bit more later how it works, but basically, the cognition plane is fitted with performance monitoring, and based on that, it can order actions to optimize the slice. That's mainly going through the orchestration and the SliceNet control plane. So to dynamically reconfigure the underlying data and control plane infrastructure. We said we can have questions even during the presentation. So
yes, if anybody has a question now is a good time. This is quite a detailed slide. So if anybody has a question, please feel free to ask it now. In fact, there is one question that has come in here on the chat box, and it is, what exactly is the bottom layer 4G, 5G network control and data plane?
Yes, down here, this is the core network, for instance, this is the core network and control and user plane nodes as specified by standardization bodies like 3GPP. So you will have all the RAN infrastructure, the core network infrastructure, and so on. And again, you know that those functionality are normally divided in control plane functionality and user plane functionality, but again, as they are specified by 3GPP, and especially in SliceNet, this is an European project, we refer to the 3GPP and that's it as a standard.
And just a follow-up question from that is, how did the SliceNet project come up with this framework? You say it's based on 3GPP, is that right? Is it based on a lot of work already carried out?
Yes, of course, whenever possible, we try to follow ETSI and 3GPP standards. And lately, we are also, of course, trying to contribute to those standards, contribute actively, meaning trying to bring to standards some SliceNet results.
Okay, thank you very much, Ciriaco. We can go back on mute now and please carry on with the presentation.
Okay. Now we can zoom a bit more in the control plane, starting from requirements that, as usual, soon became challenges as well for the design. So the main requirements we had to satisfy with when designing the control plane was that we had to offer a dynamic configuration and a customization context. That means basically offering primitives for the dynamic programming of the control and data plane. We had to abstract the underlying network technology details. And also it was required that the control plane architecture had to allow for slice isolation and scalability, because we learned that especially isolation is one of the main requirements for slicing. And also the software component composing the overall control plane had to be somehow loosely coupled with each other, so to allow individual development, deployment, and upgrade with the minimal related impacts. So those were the main requirements. And this is the detailed control plane architecture we came up. That of course is satisfying all the main requirements we just talked about. This architecture is based on two main principles: the service-based architecture and the layered approach with a set of abstraction level. When it comes to the service-based architecture, we see that the control plane functionality is achieved by a set of loosely coupled components, namely services and adapters. So the services are those ones, the blue ones, and yeah, you have the adapters. And the overall framework for the service-based architecture is mainly implemented by this component. It's called control plane service register. And you can see here you have multiple instances of services. This because the services are instantiated per slice. Which is a great enabler for isolation and scalability of the system. Also, the adapters here can be easily onboarded thanks to the service-based architecture. And in case you want to support a new added infrastructure pillars, so that the architecture can be dynamically expanded. We will be we'll offer somehow more details on the service-based architecture later. But of course, if you have questions, you can put. Just a few more on the second principle, is that is the layered abstraction. As you can see in this architecture, there are three abstraction layers. Going bottom up, the first one is what we call infrastructure abstraction. This level is abstracting the heterogeneous vendors technologies to the upper layer, because as you can see, you have different network segments. Just to mention the most common one, the radio access or the core network. And they could be provided by different vendors. So you will have multiple technologies and multiple API with a lot of technical details at this level. But the job of the adapters is to abstract those technical details and offer any independent APIs. The second level of abstraction is abstracting the slice composition. This is offered by the control plane services here, APIs. Abstracting slice composition means that at this level you don't care about the composition of the slice in terms of network segments. So you can have operation on the slice without knowing if the slice is composed only by RAN and core network, or there is also a backhaul and other network segments involved. The last one is offered by the plug and play. This is basically a customization layer. And this is offering a customized slice view and control to the verticals. We will also see a bit more on this one later. Questions here?
So yeah, there are a couple of questions here, Ciriaco. One from Orange asking, how are the end-to-end requirements handled? Because we can see the individual parts here.
The end-to-end requirements. Yeah. For the end-to-end, you mean the slice end-to-end requirements. Those are handled within the overall SliceNet framework. Yeah, we are zooming on the control plane. So I'm not sure I got exactly the question, but basically the end-to-end requirements are somehow in the slice template.
Yeah, I suppose we can come back to it at the end of the session and discuss it in more detail then, if we like to do that. And just one other question: why are there multiple adapter controller couples?
Yes, yeah, you can see multiple instances of each adapters. This is because for each vendor technology, you have a different couple of RAN adapters, RAN controllers. So, for instance, you could have here at the same time serving the slice, you can have both Ericsson radio access and the Nokia radio access. They're at the same time connected here. And of course, you will need multiple instances because there are different interface at technical level when you are here below the infrastructure abstraction level. So, so multiple adapters need to serve multiple vendors' technologies. Okay. Some more question?
That's great. Thank you. Yep. Carry on.
Okay, you're welcome. Okay, this is just text for your record. That's what I explained before. Technical achievements. Let's share our main technical achievements. Plug and play was the first one. This is, as we said, the control framework for customized runtime slice control that is offered directly to verticals. Then we achieved the realization of run and make controllers that are really supporting the run and core network slicing. We also realized the adapters to abstract the technology of the network pillars. We realized this service-based architecture framework ad hoc for the control plane. And also we realized a number of control plane services that are offering this slice dynamic configuration control context to the to other planes, mainly to the management and orchestration plane. Now I'd like to zoom in a little bit in some of the major technical achievements. The first one is the plug and play. The plug and play is a framework that is activated on demand when the new slices are provisioned, and they offer, they allow the customized control exposure, sorry, and slice view to the vertical. And this means that what is the customized slice view? If you see there are monitoring information here. that can be brought upwards to the vertical. And of course, you don't want to expose all the available monitoring, but just a restricted subset. That's why we say it's a customized slice view exposed to the vertical. And at same time, we have the customized control exposure. This means that the vertical, as you can see, going top down, the vertical can access to some configuration of the slice going down here. Of course, like for instance, it can reconfigure some quality of service parameters in the slice. And of course, again, you don't want to expose all the possible configuration to the vertical, but just a restricted subset. That's why we say it is customized. And this is the job of the plug and play. One more is running connect to slicing. Here we have realized this what we call FlexRun and LLMEC controllers. They allow the data plane programmability on a slice basis, meaning that they provide the APIs that makes possible the slice configuration indoors between slice and user equipment association to the slice. These controllers are called FlexRun and LLMEC, and they are part of an open source actually called Mosaic 5G within the Mosaic 5G platform. Last one we want to focus on is this service-based architecture. Here is the paradigm used in this architecture. You have a register. In our case, it's called control plane service register, where the what we call a service producer, that in our case is a control plane service, register to the CPSR saying, okay, look, I'm the service providing quality of service configuration. And then it can be later discovered by a consumer, typically the orchestration plane, and say, okay, it asks the control plane service register, I need to configure quality of service. Who is the service doing that? And it gets the answer, and then I can then invoke directly as a last step the APIs of the wanted service. Again, service-based architecture is something known, is also standardized, but here it was realized and customized ad hoc for the service, for the control plane architecture. A quick look on the innovation we have introduced. Plug and play. Because we consider innovation because it's going a bit beyond the current practice of exposing runtime control to verticals. The control plane itself, being an overlay control plane, coupled with the service-based architecture that allows pluggability of all the components and underlying network pillars. The architecture itself, here mainly referring to the control plane architecture, that is able to cope with heterogeneous network thanks to the couple adapters controllers. And then also the use of the run MCOR slicing controllers API that are very powerful API for runtime end-to-end slice reconfiguration. We also have one more innovation that basically allows to control the flow priority in the underlying data plane. We call it data path programmability. This is for your record, but just to show that all the components in the control plane belonging to the control plane we are shown. Those are prototype in terms of software components, and they are stored on the SliceNet Git. So you have the link there. I think almost all the components are accessible. You can download. At the end, a bit on the industry vertical application. We learned that slicing proposes slice as a solution to run a 5G use case. We learned that SliceNet is a framework to manage the life cycle of slices and control them at runtime. And in fact, we have in SliceNet project 3 5G use cases that runs on Slice. Namely, there are smart grid, e-health, and smart city. And I'd like to remind that at the end, we, as a project, we have to prove that, prove by demo that those use cases are running on the slice we provide. Of course, it's not just running, but running while satisfying at the same time the diverse requirements in terms of quality of experience and quality of service that those 5G use cases are putting on the system. To make a little bit more concrete, we have an example here that is also being prototyped. This is taken from the smart grid use case, and is a case of network slice optimization. But this is a chance to see how those planes work together, and of course including the control plane. Quickly, as you see, there are monitoring information going up to the cognition plane. The cognition plane, based on some machine learning models, is able to predict, in this case, is able to predict equality of experience degradation. And in order to prevent it, decide to take some actions. In this case, the action is to reconfigure the run sub-slice. And as you can see, the flow is going through from the cognition plane is going through the orchestration subplane that makes use of the control plane functionality. In this case, the quality of service control. In order to reconfigure quality of service parameter down here in the run infrastructure. So you see all the involvement, the QS control, the run adapters, the run controllers. This is the last one I'd like to show, and questions?
Are we at the end of the presentation?
Yes, there is just some further information. Of course, if you want to know more, or our website, email, the open source contribution, because most of the software models we've seen, they are open source as well. And then, of course,
Thank you so much, Ciriaco. That was a really interesting and informative, meaty presentation on the 5G control plane. So are there any questions for Ciriaco after that presentation? I have some here, but if anybody else would like to ask one now. So if we could go back up to slide 13, there's a couple of questions there.
13.
Yeah, so first of all, what can be controlled by verticals in the network service provider infrastructure in terms of plug and play?
So maybe it's not is the other one. It's the slide on the plug and play. This one.
That one, sorry, yep, slide 11.
Yeah, what can be controlled? Yes. As I said, typically, as you can see, you can control quality of service parameters in some of the network segments, like in the RAN or in the core network, for instance, but also something in the orchestration plane, meaning that the vertical can even orchestrate, instantiate his own vertical application. What is exactly possible to control is by the way controlled by the plug and play. We say that it is instantiated on demand when the new slice is provisioned. This is because each slice might have different subset of parameters that can be controlled. So that's also why we say they are customized to the slice. And this is actually um, um, stated, let's say, in the initial slice template. So when the slice is orchestrated and instantiated, starting from the template, the orchestration plane knows what kind of control it has to enable and what not.
And has SliceNet implemented all of these software components?
Yes, some of them are implemented from scratch. Others are taken from open source without any modification. This is the case, for instance, of the database used for the data lake. But in other case, we also make addition to existing open source, like in the case of OpenAir with the RAN and the Mac controllers. So it's mixed component from scratch, designed from scratch, components taken as they are from open sources, and taken from open sources but updated for our purpose.
Okay, very good. Thank you. Question again from Orange, is the orchestration based on standard?
Yes, it is based on standards. There will be a next one of the next webinar will be on orchestration, so they will explore all the details. But yes, and also we partially for the orchestration plane we partially using in open source, that is the open source manual that is following, as we know, the ETSI standard.
Very good. And then another question on the roles. It was on slide 13, I believe. Just if you could clarify the roles for different actors in terms of users, tenants, operators, MVNOs. They're
Probably
asking
here.
who is piloting the tool and how are conflicts handled?
Can say a bit more, maybe we can refer to these slides. Yeah, you can see already different roles. You see the verticals, the digital service provider, and down here is supposed to be the NSP, the network service provider. So normally the network service provider is a typical telecom operator like Orange, for instance, and this is the one providing the infrastructure and the NSP part of the control plane. Because we are not going to such details, but the SliceNet framework as an NSP view with planes and components deployed at NSP level, but there are also a DSP view, digital service provider, that is a bit wider. We have not gone in such details. Hope in next webinar, for sure there will be one. Because I don't have slides for that. But basically, we know the vertical role is the vertical is the one who want to run a specific 5G use case, 5G business. In the health case, for instance, in SliceNet is the vertical is identified with the national health system in Ireland. The digital service provider is the one that provide the service, the end-to-end service that can be composed by different slices. And the network service provider, instance, is the one that provide the slices that compose the end-to-end service. Maybe we can also this is not. Yeah, maybe we can also refer to this one. Okay. The network service provider is the one providing all the infrastructure here. And also the SliceNet framework in terms of software. That is, in the control plane case we have those components. Of course, then you need to put all the planes to have the full SliceNet framework.
That's excellent. Thank you very much, Ciriaco.
Yeah.
Does anybody else have any questions that they would like to ask at this stage?
But I also would like to say, if you need and interested in more specific details, you can also drop a mail to me or on the no, we don't have here an email for SliceNet. Okay, just drop a mail to me or to Jeanne, and of course we will try to answer with more detail. Yes,
that will get to us.
Yes. No, I understand that there could be plenty of questions, and hopefully we can use the question eventually also to customize the next webinar. If maybe there is more interest in some aspect when it comes to orchestration, we could focus on those one instead of others, and so on for all the other webinars, because again, we will have webinars addressing all the planes in this framework here. So this is the first one where we try to zoom a bit on the control plane. That is this one.
Absolutely. We have a few more webinars coming up. The next webinar, in fact, is on the 17th of March at the same time. It's on a Tuesday as well. And it's on cognitive service level quality of experience management. So I'm sure as we go along through the series, we'll be able to answer most of your questions, if not all of them.
Yes. Yes.
Okay, so if there are no more questions, we will close the presentation now. Please remember again that we will put the recording up on our website, SliceNet, so it will be available there for you. So we can stop the recording now and wish